Hello everyone. Today we are going to talk about how Uber handles 200 million Pinot queries every day. Here is a brief introduction about us. My name is Ujwala. I'm engineering manager at Uber Data Platform team. I lead data real-time analytics platform, which is built on Apache Pinot and Presto, which powers the various business intelligence use cases and real-time dashboards at Uber. Today, I'm going to talk about some of those use cases.
Hi, I'm Ankit. I'm a senior software engineer at Uber in the real-time analytics team. I contribute to Neutrino and Pinot internally, and today I'll be talking about some of the technical challenges that surround our use case. So over to Ujjwala.
Thank you. Before we start with the use cases, let's look at how the value of the data changes over the time. As shown in this graph, when the data is really fresh, it's seconds old or some minutes old, it's used for making a time-sensitive decisions. As the data ages, it is ideal for the traditional batch processing or for example, trend analysis or the historical data analysis. And also the data analysis also changes the human behavior, and in the subsequent slides, we are going to talk about them in detail. So it takes like 250 milliseconds to react to a visual stimulus for a human brain. And on the right side, we have the Apache Pinot powering the real-time use case, where we support 1800 QPS at 50 milliseconds. So that's how fast the Apache Pinot is. Going over to the next slide. So when we talk to the customers at Uber, these are the main categories of the requirements come from the user. There are like on high level, there are like three main categories. One is the real-time and actionable insights. As you can see on the left-hand side, the restaurant manager UI. So that is developed by the restaurant manager team, which is used by all the restaurants and the merchants across the globe. The merchants needs to know how their restaurant or the store is doing on the platform, how many orders they are getting, how much are the sales, how many missed orders are there or the inaccurate orders are there. So as you can see, they need to gain the insights which are actionable. Second category is the time sensitive decisions, and the demand and supply management provided by the Terra product at Uber is a great example in the middle. Every minute there are orders created and they need to be fulfilled by the couriers. And it is very crucial to maintain the healthy marketplace. So we always have the balance between the demand and supply. The third category is the user engagement growth. Uber powers multiple apps for the users. For example, Uber Rides app, Uber Eats app, or the Uber Freight app. And the showing the real metrics to the users is key for them to engage with the app. So in the nutshell, what the users need is the fast access to the fresh data at scale. By fast, we mean the lower response times. Fresh means the high data freshness, and the scale refers to the high throughput. The throughput can be high ingestion throughput or the very high query throughput. So considering these requirements, we have introduced the consolidated real-time analytics platform at Uber, and this is just a word cloud that shows the various orgs or the various teams that we powered within the Uber with our platform. So starting with our first use case, which is a great example for the external analytics, Uber Eats Manager, or formerly known as the Restaurant Manager. This is one of the oldest legacy applications powered by Apache Pinot at Uber, and it is to the date, it is still active. Few of the challenges that were reported by the customer were that they wanted the unified web mobile interface for all the merchant metrics, and they also want to get these insights about the customer satisfaction in the real time. So we power various analytics metrics on the restaurant manager UI, but to name a few, the sales and insights, we power both historical and the real-time trends. For the conversion funnel, which gives the insights into how many people looked at your restaurant versus how many people actually ended up ordering. So that is the conversion funnel. And the real-time customer feedback helps you to respond to the customers in real time and address the issues reported by the customer. Top selling menus will give you more insights into what are the menu items which are very popular, and then it will also help with the inventory management for the restaurant. Second example is operational intelligence, and we have a very great example of Sharon team, which does the automation for the merchant monitoring. So Sharon is a framework for controlling the demand at a merchant level through the enforcement of the real-time rules. To give an example, most orders that are created on the Uber Eats platform are assigned a courier very instantaneously. However, there are like certain orders where the courier is not assigned, and as a result, it creates a very bad experience for the restaurants and eaters, because restaurants are already working on those orders, but the couriers are not matched. To avoid this, the Sharon team came up with this automation framework where they can do the more finer grained merchant level monitoring and apply the rules to a specific merchant. In early February 2020, when the COVID hit, there were a lot of concerns from the restaurants as well as the regulatory compliances about the crowd gathering outside the popular chains. Many merchants and the earners were losing the revenue because they had to close the businesses and close the restaurants because of the COVID restrictions and the policies. And Uber Sharon team stepped up in that time, and they came up with the various merchant level monitoring rules that will control the crowd outside the restaurant, that will also disable the restaurants in the app if there are certain number of outstanding orders at the restaurant. And that helped this real-time monitoring allowed us to quickly reopen the enterprise stores like McDonald's and the KFC. And by May 2022, we had fully rolled it out to the multiple restaurants in the Europe. If you want to know more about this use case, feel free to refer to our blog. The link is at the bottom of the slide. And the third category is about the user-facing apps to increase the user engagement over the platform. One of the very good example of that is the Uber Freight Carrier Scorecard. Not many people are aware of the Uber Freight business. The Uber Freight is a platform that connects the shipper with the available carriers on the carriers, and it also gives a opportunity for the carriers to browse through the listings, browse through the shipment listing, and see their upfront pricing and the book their shipment on the platform. Providing the reliable service to the shippers is critical for the Uber Freight in order to gain their trust, because the carrier's performance could significantly impact the reliability of the Uber Freight platform. We need to be transparent with the carriers about the level to which we are holding them accountable, providing them with a clear view of how they are doing on the platform, and if needed, what are the improvements they can do. And to do that, actually, Freight team came up with this bunch of requirements to us, and then we helped them build this career scorecard in the app where they're storing the raw data about these metrics on the Apache Pinot and then querying them in the real time at a very low latency to power this application. Last but not the least, these are various features that we power in Uber Eats app. If you're using the Uber Eats app, there is a high probability that you are already aware of these features. For example, each search history that shows the most recent search terms that you have searched at in the Uber Eats app, or the trending searches by the city, like what are the popular items in your locality, or it could be the orders near you, which gives you the information about what other eaters in your locality are ordering from. So these are the features which increases the user engagement with the Uber Eats app, are powered by the real-time analytics platform built by my team. And now over to you, Ankit, to talk about the technical details.
So I'll talk about some of the technical challenges that surround our use case. So as Ujwala mentioned, that we have a lot of users internally for the real-time analytics platform, and these are across different lines of businesses. So it's not just Uber Eats or Uber Rides. We also have Uber Freight. We have a lot of internal tooling, a lot of marketing analytics that needs to be done using our platform. So what ends up happening is that given we have so many diverse use cases, we also have a large amount of technical challenges associated with each of them. So, for example, like you could have tables which are of different sizes. You could have a very small table which are like less than 100 GBs, which is basically nothing for Pinot. And you can have also larger tables, which also Pinot can handle, but you'll have to scale horizontally accordingly. You can also have QPS which are less than 10, which you can also have QPS which is more than 1000. It depends on like use case to use case. And we have different types of tables, as you might already know. Pinot has offline tables, real-time tables, upsert tables. All of these have their own caveats around how to use them. All of them have their own feature sets as well in some sense or the other. And then we have a lot of query features that keep on coming every now and then, because Pinot is evolving at a very fast rate. As you might see, new features are being rolled out every version, and they're not just like very small features, they're very big features. So like while Pinot is rolling out features, our customers are also trying to learn about these features. And as more and more features keep on getting added, like people definitely want to use them, but they also have a learning curve in the beginning. So the question then becomes is that if we have so much flora and fauna in the technical landscape, how do we support this sustainably? Because we have hundreds of users. So not every user can be an expert in Pinot. At the same time, we don't want them to be an expert in Pinot. We want them to work on their use case so they can deliver it fast, and at the same time let the platform take care of doing most of the heavy lifting. So that's pretty much what the challenge is, that what I'm going to talk about today. The key idea that we have tried to focus on is to keep the platform as self-serve as possible. So the goal is that we have hundreds of users. Not all of them can leverage the self-serve platform because most of them would be using very new features which have just been released in the last Pinot version, and we might still be on a version which is like a couple of versions prior to that. So we are still upgrading the versions, and at the same time we are also learning about the new features. So not every user can just basically start using the self-serve platform. What we try to do is we try to make sure that as many users as we can, maybe like 95% users, 99% of the users, they're able to do what they want without ever having to go into the details of how Pinot works or how Neutrino works, which I'll get to in a second, or how the data management internal layers work. So this diagram basically gives you a high level of how the platform landscape is organized. So at the very left, we have the data workflow platform. So this is just like an umbrella term for a lot of technologies that we have that allow users to create new data ingestion jobs or data transformation jobs. And the key goal here is that we don't want users to write code for everything. We want them to have something like a drag and drop functionality where they can go in and say, okay, I want my data from this Kafka topic to go into this Pinot table. And they can also specify which indices they want. And they can also specify any other configuration that may be needed for the Pinot table. So we want them to interact at that layer. We don't want them to go deep into streaming platform or batch analytics platform. So on the right, you can see the query layer, which is basically consists of one service, which is Neutrino. So Neutrino is an internal fork of Presto. As you might know, Presto is primarily designed for interactive analytics. Like most of the use cases that are served across the industry are for interactive analytics, which is essentially like you're looking at latencies of 1 to 10 seconds maybe. And data volume is also high compared to Pinot. And it's usually you're looking for lower QPS numbers there, like maybe like around 10, 100, and so on. The real-time analytics use case, what we have is we have thousands of QPS. We have latency expectations which are maybe like less than 100 milliseconds. And we also have lower amount of data. So it's a different take on Presto. It's a different internal fork of Presto. And that's the primary layer that users interact with to submit their queries and do their analysis, or integrate it with the backend service where their backend service would be sending the queries, and they'll be serving some end user app features like the ones that Ujwala mentioned a few slides ago. So to keep the platform as self-serve as possible, we have invested on broadly three categories. We have reliability, automation, and observability. So I'll talk about all three of these categories in the upcoming slides. So first, talking about reliability, I think as everyone might know, we need the systems to be reliable for them to work. But for Pinot's use case, since we have a lot of users using our platform, we can, and all of those users, they are coming up with new use cases every now and then. So for example, not every use case will have a lifespan of years. Some of the use cases might have a lifespan maybe 3 months or 4 months. So if users are moving so fast, we need to be reliable to make sure that we are not becoming the bottleneck for the business. And given that we're serving like so many users across all lines of businesses that we have, it's very important that for us to be reliable. And some of the ways that we make sure that we are reliable is we leverage some of the Pinot concepts that are there already. For example, for resource isolation, we use the tenant concept in Pinot to make sure that at least for the broader use cases, we have dedicated tenants. And that way, an outage on one tenant won't affect the other use cases. So you don't want the entire RTA platform to be down at the same time. Maybe one system is down, which might be unavoidable, but you cannot have the entire platform down because that means like hundreds of users, multiple lines of businesses, going back to that again. So resource isolation is something very basic, but we use it very fairly effectively. So even within a tenant, sometimes we'll have cases where we are serving multiple use cases from the same tenant. So so let's take the restaurant example here. So we serve many use cases for restaurant team, but not all of them warrant a new tenant because you cannot have these many tenants, these many servers just for very small use cases. And if let's say you have 10 or 20 use cases, then obviously it doesn't really scale that way. So we need to find a way where we can say, okay, if this use case is causing an issue, then we need to stop that use case temporarily. And one idea there is that you basically reach out to the user and you try to tell them, okay, can you stop your traffic or something like that. But that really doesn't work, because your teams could be like in different time zones. It might take a bit of while, and any sort of downtime for high tier services is going to be very critical. So we have something called as a rate limiter internally. It's built into the infrastructure platform at Uber. In that sense, the platform is like really mature. So you could say that for my service, I only want 100 QPS from this use case 1 and maybe 200 QPS from use case 2. And let's say during an outage, we realize, okay, use case 1 is causing this, then we can put a tighter rate limit for that use case 1. So only use case 1 is impacted. So that way we are able to fine tune at a use case level as well, like what works in times of like dire needs. And we also have like more features around controlling which traffic goes through and which traffic works when there are some special scenarios. I'll come to those in one of the upcoming slides. Next, talking about automation. So I think automation, as you might know, some of the things are very obvious, but you basically don't want the cluster creation or adding of hosts or removing of hosts to be a bottleneck. And by bottleneck, I mean it shouldn't take very long. At the same time, it should work reliably every time. And ideally, if it can be automated completely, that would be the best place to go. We have like a one manual step where we say, okay, we want like 3 nodes for this cluster, and we just click a button and it just basically adds the nodes that are needed there. We'll have to do like some rebalancing for the Pinot table that goes with the Pinot territory, but it significantly reduces the amount of time that we spend on ops. And this has been something really useful that we have rolled out in the last 6 months. And it also takes care of taking care of scenarios where one of the hosts, let's say, dies. Then how do you handle that scenario? So we have automatic replacement of the host as well with the new technologies that we have onboarded it to recently. One of the things that we're working on these days is detecting expensive queries in real time. So as you might know, like not all the queries are same. Some queries might be more costlier than others. Some queries might have more QPS than others. So there needs to be a way where we can say that we are able to detect these queries in real time, and we are able to block those queries in real time as well. So in case, let's say some user starts a use case and that user has been using Pinot for a while, so maybe they don't know that their queries is very expensive, and maybe let's say they start with 50 or 100 QPS, which doesn't seem like a lot for Pinot, but it could be if the query is like expensive and it's not optimized properly, then it could cause an issue with production systems. So ideally you test these things in staging, but obviously like there could be cases where people leave out one particular detail from the testing, and that causes an issue. So for such scenarios, we are working on implementing a automatic way of detecting these expensive queries, an automatic way of blocking these queries in real time as well. In terms of observability, I think it's like I think it's general to most software engineering and most microservices at Uber, but the complexity which we get with Pinot is that we have a lot of dimensions that we need to look at when there is an issue or when we want to look at the cluster health. For example, like let's take the number of documents case. So this metric could be emitted for per table, per tenant, per host. And during an issue, it might be one host which is causing an issue, or it could be like multiple hosts which is causing an issue. And it might be because of one table or multiple tables. So essentially, you need to like look at all of those dimensions to figure out what the exact root cause of my solution of my issue is. So for example, let's say someone onboards an offline table and they don't realize that it's a very large table. We have safeguards around those to make sure that those issues don't occur. But let's say like for some reason this one passed through, and now we are suddenly like having some production issue. So at this point, you need to find out which table is causing it, and that's the key part there. Like you need to find out what's the exact source of the issue before you can go about fixing it. So we have all of these metrics. We have a bunch more as well, but importantly, we have metrics on all the dimensions. So we are able to see like whether it's a table which is causing it, whether it's a tenant that's having an issue. And based on that, we are able to react in real time and solve the issues in real time. But it's a very basic thing, but it needs, the details need to be there in the metrics. Otherwise, you won't be able to debug a lot of the issues that you might see. Coming on that note, actually, so recently we had an issue where one of the queries, it started causing high CPU utilization on one of the servers. So not go into the details there, but essentially the problem statement there was, I have one of my Pinot servers which has high CPU utilization. I have maybe like 5 Pinot servers which have high CPU utilization. How do I figure out why it's happening? At that point, you might look at all the dimensions and see, okay, I found out which table is causing it, maybe. But in this case, what was happening was that all the QPS looked mostly the same. So with table level, we couldn't see much. Tenant level, we couldn't see much. So what ended up helping us out there was something we have built recently internally, which is analyzing query traffic in real time. So the way we do that is we essentially have integrated query fingerprinting into Neutrino. And the way it works is, as you can see, you basically stub out all the literal values of your query and you create a fingerprint out of it. This is similar to like how fingerprint is used throughout the industry. Like GCP also has it. Percona also has a tool around it. So most I think evolved storage systems use this to monitor their traffic. But in our case, it's very helpful, and because in most of our cases, it's backend services which are hitting us. So which means that the query shape is the same. It's just that people change the literal values based on some API calls that might be coming in. So for example, like the freight UI that we showed before, like the UI doesn't change. So the query is not changing, but the user might be changing. So that's the only change that's happening between queries. So you don't need to consider each of the queries as a separate query. You basically collapse all those queries into one fingerprint, and you look at that fingerprint and see what's going on with your cluster right now. So this is how like one of our dashboards looks like. So as you can see, like we have for this particular user, we had within the last 3 years 500,000 queries, but actually there are only like 160 distinct queries. And we have a real-time analysis here where we can see for a given query shape how much QPM I am getting and how much is the Pinot metrics for each of them. For example, Pinot has this metric called number of entries scanned in filter. We have this metric per fingerprint, and we can analyze it per fingerprint, and based on that we can figure out whether it's one particular query which is causing it. Going back to the incident that I talked about, so in that case we were able to figure out exactly which query was causing it, and we were able to reach out to the user to stop that particular query. But then we realized that we don't really need to do that. Like we shouldn't really need to reach out to a user to ask them to block a query. So we also ended up adding another dynamic config system within Neutrino where you can basically, without doing any deployment, tell Neutrino that we want to stop this particular query, and it will start blocking that query. So yeah, that feature has been really helpful. We have used it for a bunch of other use cases as well internally, and we presented that recently in PrestoCon, so you can take a look there. So yeah, that's pretty much what we had to share today, and thanks everyone for inviting us here. Like it was really fun, and we hope to come back again soon.
And hope you enjoyed our talk today. Thank you so much.
Thank you.